Imagine a future where the most dangerous spy is not the one hiding in the shadows, not the one wearing a disguise, not even the one tapping your phone, but the one you ignore, the one you wave away, without thinking the one you assume is nothing more than a harmless insect buzzing past your ear. Imagine a world where a machine the size of a mosquito can quietly enter a room, listen to secrets, watch decisions being made, and leave without anyone ever knowing it was there. This is not science fiction anymore. This is not a distant fantasy. This is a direction modern espionage is already moving toward. And if you want to understand how the future of spying is being built right now, then stay with this story until the end, because what you are about to hear will change how you look at technology security and even the smallest things around you. And if you find this story valuable, remember to support the channel by liking, sharing, and subscribing, because the more you support it, the more deeply we can explore the hidden world of intelligence and secret technology. For most of history, espionage has been about people. It was about agents crossing borders, stealing documents, memorizing maps, and risking their lives to bring back information. Then it became about machines. Cameras became smaller, microphones became more sensitive, satellites began to watch from space, and computers started to collect more data than any human ever could. But now, a new chapter is opening, one where the line between machine and insect begins to blur, and where the smallest device can sometimes carry the biggest strategic value. When engineers and military researchers talk about mosquito-sized drones, they are not imagining them as tiny fighter jets or miniature bombers. Their real value is not in destruction. It is in observation. Espionage has always been about seeing what others want to keep hidden, hearing what is meant to stay secret, and learning what changes the balance of power before anyone else does. A drone that is small enough to be mistaken for an insect, in that sense, almost a perfect spy tool. It does not announce itself. It does not look threatening. It does not trigger the same alarms that a larger machine or a human intruder would. Because of their extreme size, these drones could, at least in theory, enter places that are difficult or dangerous for humans and impossible for larger machines. They could slip through open windows, ventilation gaps, cracks in walls, or crowded indoor spaces. In environments where cameras are banned, guards are present, and security is tight, a tiny flying device that looks like part of the natural background could pass through without raising suspicion. It would not look like a spy. It would look like noise, like nature, like something the human brain is trained to ignore. In the world of intelligence, information is often more valuable than firepower. Knowing who is meeting whom, what is being discussed, or what equipment is inside a room can change the direction of political, military, or economic conflicts. Sometimes a single image, a few seconds of audio, or a brief glimpse of a document is enough to confirm suspicions or expose a hidden plan. A mosquito-sized drone does not need to record hours of high-definition video. It only needs to capture the right moment, at the right time, in the right place. Another factor that makes such technology attractive to intelligence agencies is plausible deniability. If a device this small is discovered, it can be extremely difficult to immediately prove who deployed it. It might look like an experimental prototype, a research project, or even a strange piece of debris. This kind of ambiguity has always been useful in espionage, where direct attribution can escalate conflicts and force public responses that nobody wants. The less visible the tool, the easier it is to deny its existence or its origin. At the same time, it is important to stay realistic. These drones are not magical spies. Their size creates as many problems as it solves. Battery life is limited. Signal strength is weak. Sensors are tiny and cannot compete with the quality of larger systems. They cannot stay in the air for long, and they cannot transmit large amounts of data over long distances. In practice, they would be used as specialized tools for very specific, short, and high-value missions. Moments where even a small piece of information is worth the risk and the effort. In other words, mosquito-sized drones are not about watching everything all the time. They are about seeing what was previously unreachable. They are about opening doors that were once closed to both humans and machines. And in the secret world of intelligence, opening even one new door can change the entire game. This naturally leads to a question that fuels both fear and imagination. Can a mosquito-sized drone be turned into a weapon? Technically, almost anything can be weaponized. History is full of examples of tools that were never meant to be weapons, but became ones anyway. But in practical terms, at least today, the answer is no, not in any meaningful way. At this scale, the drone's biggest limitation is payload capacity. It can barely carry its own power source, control electronics, and sensors. Adding any kind of weapon would almost certainly make it too heavy to fly. Some people imagine scenarios where such drones inject toxins, explode on contact, or act as tiny assassins. These ideas make for dramatic headlines and thrilling movies, but the engineering reality is far less dramatic. Delivering a harmful dose of anything requires volume, stability, and precision, all of which are extremely difficult to achieve at insect scale. Even larger drones struggle with accuracy in complex environments, and a device this small would be constantly affected by air currents, temperature changes, and signal interference. There is also the problem of control and reliability. Real-world environments are not clean laboratories. They are chaotic, unpredictable, and full of interference. A mosquito-sized drone would be one of the most fragile platforms imaginable. A sudden gust of air, a change in temperature, or a weak signal could easily send it off course or bring it down. As a weapon, it would be unreliable. As a surveillance tool, it is risky but potentially useful. That said, history teaches an important lesson. Technology evolves. What is impossible or impractical today can become feasible tomorrow. While current mosquito-sized drones are overwhelmingly focused on surveillance and research, it would be irresponsible to pretend that weaponization will never be attempted. Even if it remains highly impractical for now, the mere possibility forces security planners and intelligence agencies to think ahead. For the present, however, the realistic threat is not that these drones will shoot or explode. The real threat is what they can see, what they can hear, and what they can secretly record without being noticed. In espionage, knowledge is power, and silent knowledge is often the most dangerous kind. It would also be a mistake to view this technology only through a spy movie lens. In reality, insect-scale drones could have many different applications, both positive and controversial. In the military and intelligence world, their role is obvious. Reconnaissance, inspection of dangerous or inaccessible areas, and short-range surveillance in high-risk environments. They could be used to check inside damaged buildings, caves, tunnels, or dense urban areas without risking human lives, providing information before soldiers or rescue teams ever enter. In civilian and scientific fields, the possibilities are just as significant. Researchers could use such drones to study wildlife without disturbing animals, to inspect fragile historical sites, or to explore environments that are too small, too dangerous, or too unstable for humans. After earthquakes or industrial accidents, tiny drones could enter collapsed structures and search for signs of life where no human or large robot could safely go. In medicine and biology, similar micro-robotic technologies are already being explored for internal imaging, targeted drug delivery, and minimally invasive procedures. While flying mosquito drones are not the same as medical micro-robots, the engineering principles often overlap. Advances in one area can influence many others, and the line between military, civilian, and medical technology is often thinner than it looks. In industry, tiny drones could help inspect machinery, pipelines, or tight industrial spaces where sending a human would be risky, slow, or expensive. A dangerous job could become a remote operation, reducing risk and saving time. This is how many military technologies, eventually spread into civilian life, not through dramatic headlines, but through quiet, practical use. But in the world of espionage, every new tool also creates new risks. The moment news about mosquito-sized drones reached global media, it triggered a familiar reaction, a mix of fascination and fear. Engineers and scientists praised the achievement as a remarkable example of miniaturization and bio-inspired design. Security experts, lawmakers, and privacy advocates raised immediate red flags. The biggest concern is privacy. If a device the size of an insect can enter homes, offices, or private spaces without being noticed, then traditional ideas of surveillance detection become almost useless. You cannot easily hear it. You cannot easily see it. You may never even know it was there. This changes the balance between those who watch and those who are watched. It raises serious ethical questions. Should such technology be regulated? Who is allowed to use it? Under what circumstances? What counts as illegal surveillance when the tool itself is almost invisible and leaves little to no trace behind? These are not just technical questions. They are political, legal, and moral ones, and different societies will answer them in very different ways. There are also concerns about misuse by criminals, corporations, or authoritarian systems. A tool designed for research or security can easily become a tool for blackmail, spying, or harassment if it falls into the wrong hands. History shows us that powerful technologies rarely remain limited to their original ideal purposes. They spread, they are copied, and they are adapted in ways their creators never fully control. On an international level, this technology adds to the growing anxiety about a new kind of arms race. Not a race for bigger weapons, but for smaller, smarter, and harder to detect ones. A race where visibility is no longer a strength, and invisibility becomes the real advantage. In such a world, the question is no longer just what you can destroy, but what you can secretly know. Looking toward the future, one thing seems almost certain. Machines will continue to get smaller, smarter, and more autonomous. Mosquito-sized drones today, limited and fragile as they are, represent a direction rather than a final product. Just as early computers were massive, slow, and unreliable before becoming invisible parts of everyday life, microdrones are likely to improve in efficiency, control, and coordination. The most significant change may not come from individual devices, but from swarms. Dozens, hundreds, or even thousands of tiny machines working together, mapping environments, monitoring activity, and performing complex tasks that no single device could handle alone. In espionage, this could mean a shift from single-agent operations to networked, distributed surveillance, where information is gathered quietly and continuously by machines that are almost impossible to notice. In warfare and security, this points to a future where influence comes not from visible force, but from invisible presence, from constant, hidden observation, from knowing more about your opponent than they know about you, without ever revealing how you know it. This is a dream for intelligence agencies, and a nightmare for anyone who values privacy and secrecy. Societies will be forced to respond. New detection systems, new laws, and new norms will have to emerge to deal with technologies that blur the line between the physical and the digital, between machines and insects, between observation and intrusion. The age of the mosquito-sized drone is not about a single gadget. It is about a new philosophy of technology. Smaller, quieter, closer, and harder to escape. Once, humans looked at insects as symbols of weakness and insignificance. Today, we are learning that size means nothing in the face of information and technology. A machine small enough to be ignored can still change how wars are planned, how secrets are stolen, and how privacy is defined. And this is where the real spy story begins. Because behind every new tool, there is always a new method, a new tactic, and a new way to exploit both the technology and the human mind. In the next part of this story, we will go deeper into the intelligence angle, how such devices could be integrated into real espionage operations, what kinds of missions they would actually be used for, where they would fail, how they could be detected, and how the silent war between those who want to see and those who want to stay hidden is already evolving. The Mosquito-Sized drone is not the end of espionage. It is the beginning of a new, quieter chapter where the most powerful spy may also be the hardest to notice. And perhaps the most unsettling thought is this: the next time something buzzes past your ear, the real question may not be, is it just a mosquito, but who or what is watching through it? To understand how a mosquito-sized drone could actually be used, we need to think like an intelligence planner, not like a science fiction writer. Real spy operations are not about spectacular explosions or dramatic confrontations. They are about preparation, patience, and precision. A device this small would never be sent on a mission alone. It would be part of a larger system, combined with human sources, cyber surveillance, satellite data, and traditional reconnaissance methods. Its job would be to fill gaps, to reach places where other tools cannot, and to confirm details that matter. Imagine a secure facility where no phones are allowed, where windows are sealed, and where guards carefully check everyone who enters. Traditional surveillance might tell you who goes in and out, but not what happens inside. A mosquito-sized drone changes that equation. Released from a nearby location, it could drift toward an open vent, a partially open window, or a service corridor, not because it is unstoppable, but because it is easy to overlook. Once inside, even a few seconds of audio or a single clear image of a document on a table could be worth more than months of guesswork. In intelligence work, timing is everything. A micro-drone would not need to stay inside for long. In fact, the shorter the mission, the better. Less time in the air means less chance of being detected, less chance of failure, and less chance of leaving traces. This is why such devices would likely be used for very specific tasks. Confirm a meeting is happening, verify the presence of a certain person, check whether a piece of equipment is in a room, or listen for a key phrase in a conversation. These are small pieces of information, but in geopolitics and security, small pieces can change big decisions. Another realistic mission profile would be reconnaissance in dangerous or inaccessible environments. Think about collapsed buildings, underground tunnels, or damaged industrial facilities. Sending humans into such places is risky and sometimes impossible. Larger robots or drones might not fit. A mosquito-sized drone, even with its limitations, could go first, mapping the space, checking for movement, or identifying hazards. In military or counterterrorism operations, this kind of advanced information can save lives and prevent mistakes. But espionage is not only about gathering information, it is also about protecting your own secrets. The moment one side gains a new tool, the other side starts working on ways to detect and defeat it. This is the invisible arms race that has always existed in intelligence work. For mosquito-sized drones, detection would be one of the biggest challenges. Traditional security systems are designed to look for people, vehicles, or large devices, not something that looks and moves like an insect. Future counterintelligence systems might rely on new kinds of sensors, detecting unusual radio signals, abnormal movement patterns, or tiny mechanical sounds that humans cannot hear. There might be secure rooms with controlled airflow, special lighting, or electromagnetic shielding, designed not for comfort, but to keep out things that are too small to see. In other words, the existence of micro-drones would not just change spying, it would change architecture, security design, and even how buildings are constructed. No tool in espionage is perfect, and mosquito-sized drones would have their own list of weaknesses. Battery life would always be a limitation. Even with the best miniaturized power sources, flight time would be short. Signal range would be limited, especially in dense urban environments or underground locations. Control would be difficult because at that scale, even a small air current can change the drone's path. This means operators would need to plan missions carefully, choose the right conditions, and accept that some drones would be lost. And loss is another important point. In intelligence work, Losing equipment is sometimes acceptable, but losing control over it is dangerous. If a drone crashes inside a sensitive area and is found, it could reveal not only that surveillance is happening, but also give the other side clues about the technology being used. This is why advanced intelligence agencies often build tools that can destroy their own data or disable themselves if they fail. Even at insect scale, similar principles would apply. There is also the human factor. Technology does not replace human intelligence. It changes how it is used. A mosquito-sized drone might provide images or sounds, but someone still has to interpret them, connect them to other information, and decide what they mean. Spies are not just collectors of data. They are analysts, planners, and decision makers. The danger of relying too much on tiny machines is that it can create a false sense of certainty. The belief that if you can see something, you fully understand it, which is rarely true in the complex world of politics and conflict. From a strategic perspective, the real power of microdrones may come not from individual missions, but from how they fit into larger intelligence systems. Imagine a future where small drones, satellites, cyber tools, and human sources all feed into the same network, constantly updating a picture of what is happening in key locations around the world. In such a system, a mosquito-sized drone is not a star player. It is a silent contributor, adding small but critical details to a much bigger puzzle. This also raises the question of escalation. If one country or organization starts using such tools, others will follow, not because they want to, but because they feel they have to. In intelligence and military history, this pattern repeats again and again. One side introduces a new capability, the other side rushes to match or counter it, and soon what was once extraordinary becomes normal. Over time, the threshold of what is considered acceptable surveillance shifts, often without the public fully realizing it. The risks are not only international. Domestically, such technology could challenge legal systems and civil liberties in ways that are difficult to predict. Laws are usually written with visible tools in mind: cameras, microphones, wiretaps. A device that is almost invisible and leaves almost no trace forces lawmakers and courts to rethink what privacy means and how it can be protected. Without clear rules and oversight, the same tools that protect security can also undermine trust. There is also the question of cost and accessibility. At first, such technology would likely be expensive and limited to the most advanced research institutions and intelligence agencies. But history suggests that miniaturization and mass production eventually make technologies cheaper and more widespread. What begins as a secret military project can, over time, become something that criminals, corporations, or private groups can also access. This is not a hypothetical fear. It is a pattern we have seen with many technologies, from encryption tools to drones themselves. In the spy world, this creates a new layer of complexity. Intelligence agencies would not only have to worry about rival states, but also about non-state actors using similar tools. Industrial espionage, political manipulation, and even personal blackmail could take on new forms if tiny, hard-to-detect surveillance devices become easier to obtain. The battlefield of information would become even more crowded and even harder to control. At the same time, it is important not to fall into pure fear. Technology is not destiny. How it is used depends on choices made by governments, institutions, and societies. Microdrones could be regulated, restricted, and monitored. Detection technologies could improve. Legal frameworks could adapt. The future is not written by engineers alone. It is written by how people decide to live with what engineers create. In the long run, the story of mosquito-sized drones is not really about drones at all. It is about a deeper trend in human history, the constant push to see more, hear more, and know more, with less risk and less visibility. From the first spyglass to satellites in orbit, from hidden microphones to cyber surveillance, every generation finds new ways to extend its senses. Micro-drones are simply the next step in that journey, smaller, quieter, and closer to the edge of what we can notice. And this is why, for intelligence agencies, such technology is both exciting and dangerous. Exciting because it opens new possibilities. Dangerous because it changes the rules of the game. And when rules change, mistakes become more likely, misunderstandings become more serious, and the consequences can be harder to control. In the end, the Mosquito-Sized drone is not a miracle weapon, and it is not an unstoppable spy. It is a tool, powerful in some situations, useless in others, risky in all of them. Its real impact will depend on how it is combined with other tools, how carefully it is used, and how responsibly it is controlled. The silent wars of the future will not be fought only with soldiers or missiles, but with sensors, data, and decisions made far away from the places being watched. In that world, the smallest machines may play roles far bigger than their size suggests, not because they are powerful on their own, but because they change what is possible and what is impossible in the endless struggle between those who want to hide and those who want to see. And perhaps that is the most important lesson of all. In the age of invisible technology, security is no longer just about walls and guards, and privacy is no longer just about closed doors. It is about understanding that the battlefield has moved into spaces we can barely see, and that the future of espionage will be shaped not by what is loud and obvious, but by what is quiet, small, and easy to ignore. If you found this deep dive into the hidden future of espionage and micro-drone technology interesting, make sure to like this video, share it with others who care about intelligence, security, and the future of technology, and subscribe to the channel for more in-depth stories from the secret world of spies, science, and strategy. Your support helps this channel continue exploring complex topics in a clear and responsible way. This video is created for educational and informational purposes only. It is based on publicly available discussions, research, and technological trends at the time of production. It does not promote fear, violence, or the misuse of technology, and it does not take any political or military side. All topics are presented in a neutral and analytical manner. The purpose is to inform, not to instruct or encourage harmful activities. Technology evolves rapidly, and interpretations may change over time. Viewers are encouraged to think critically, verify information from multiple sources, and form their own informed opinions.